So today I came across this interesting case. There is no history available, unfortunately. Um, so you see there is dilatation of bilateral ventricles. At the same time, you see there is something funny going on here because there should be corpus callosum right here. So you think, oh, there is a hydrocephalus and there is a corpus callosum absent probably. Uh, Bilateral thalami looks normal. You see the horns, temporal horns are there. As you go down, you don't find the vermis, um, the tonsillar vermis here. So, so you see the fourth ventricle is actually opening outside into the retrocerebellar space, which looks like a Batman kind of thing. So as this is happening, you're wondering like what's going on, and I get confused because I was thinking, oh, there's a corpus callosum agenesis with the hydrocephalus, and when I'm scrolling the sagittal images, I see aqueduct of Sylvius is not what it should be like because everything is opened or opened wide except this little fellow here. So I'm thinking, oh, maybe there is a um, stenosis because of the aqueduct of Sylvius, being a bigger or something. There is some congenital stenosis here, which is leading to hydrocephalus, but still, it doesn't explain why the corpus callosum is absent. At the same time, I look at this thin kind of line which is going from frontal to the occipital, where it's supposed to be fornix supposed to be there. So I trace it back, and actually that's what it is. Most probably that's fornix. So I'm like, okay, so this is not really holoprosencephaly, obviously, because you see there is a interhemispheric fissuring going on. So this is not some at least not lobar or semi-lobar type of holoprosencephaly. And when you go for the lobar holoprosencephaly, there is not much hydrocephalus component in it, and neither is there is any corpus callosum agenesis component except maybe anteriorly when you're talking about lobar holoprosencephaly. So I get confused. I'm like, oh, come on, like this case is very tough one, what to do? And I start searching it on the OMI, and here I found this thing comes under the syndromes which in the rare diseases obviously as L1 syndromes, especially HSAS, which stands for X-linked stenosis, aqueductal stenosis. So I Google it and I find there are many cases. Okay, yeah, right here on the OM search, X-linked hydrocephalus syndrome. So I Google it, I search it on NIH mainframe and everywhere, and this is the closest one I find to the entity where there is a problem in the corpus callosum, and as well as there is a hydrocephalus. Then I was wondering why the vermis should go crazy, so I searched this, and apparently there is a vermin cerebellar agenesis too. Yeah, cerebellar hypoplasia too. So sometimes there can be brainstem could be smaller as well as underneath the pyramid also. So yeah, this so whenever you come point is when you come across hydrocephalus and you find something which is not fitting in, like corpus callosum agenesis, don't really give up the case thinking it's you know benign sort of thing. It may not be that. And there's one more. Yeah, this was also a good article which I found by, I'll just tell you the name of it. Yeah, by Tully, Hannah Tully, and William Dobbinus. Where are they from? Oh, Seattle. Okay, so Center for Integrative Brain Research. Okay, that's a cool thing. Okay, so infantile hydrocephalus, a review of the classification and blah 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 blah. And when you go down, you find this classification system here, and there it is. The first one, there is a point of extraction is aqueducts, and you have this mutation in the most patients, but it's not specific, and it is X-linked inherited. So our patient is girl, so I'm thinking I'm 5 months old, so I'm thinking X-linked. What happens to the a boy like who has X and yeah, what happened to the boy with the XY? Maybe they die in in womb itself, like, and only the females who have XX with one of them being mutated survive, or how does it work? Like, I'm not really sure about the inheritance pattern here. So yeah, but however, the radiologically speaking, I think this is the most close one to get. If you have any other ideas, please write down in comments. I would like to know about it more. And thank you so much for your time. I found this X-linked hydrocephalus, which is written in the book Mami Yamasaki, likely from Japan. Has written a good chapter on it. I won't go into much details, but I will just show you how radiologically what are things the authors have found significant. So one of the things is hypoplasia of corpuscalism, uh, which will lead to this Salkayangara looking weird. Um, Sorry about that. Let me check. What about Arcus? Arcus has a very gross hydrocephalus, so you can't really figure out Sulci and Gyri above that. No, it's all flattened. Can't really figure that out. Fine. Then what you have is enlarged quadrigeminal plate, which is right here. Let's compare with Arcus. Enlarged, maybe, may not be. Then, okay, I can do something cooler. Yeah, cool, isn't it? You can close up things which you don't need, and alright, I just need these two things. Okay, so okay, don't go crazy on me now. So what's this? I I should accept that I overlooked that little thing. Oh wow, that is parse. Yeah, that is the thing which connects the thalamus, massa intermedia. What we were saying? I don't know. I said some parse, but that made no sense, obviously. So pars intermedia. So yeah, there is actually enlargement of pars intermedia. I don't know how did I overlook that. I don't. Okay, cool. Then what else? And you have. Okay, why are you going crazy on me? Okay, just hold on. What else you have? Then you have D, which is hypoplasia of cerebella vermis, which is there, which is hypoplasia. Okay, I can do something more cooler. Really, I can make it one on you. I can just take a snapshot of this damn thing and mark it out for you. Because I have surface. Okay, so one thing is massa intermedia. Okay, second thing you have enlarged quadrigeminal plate. I'm just saying enlarged Q plate because I don't like to write. Okay, and what else? Then you have this thing absent. Okay, question mark, where it is? It is absent or hypoplastic. Hypoplastic. Cool. And all these things. Okay, this is massa intermediate. And all these things come together to make X-linked, yeah, hydrocephalus. And I was telling you, I was wondering that what kind of inheritance it is. So turn out it is actually X-linked recessive. So that makes total sense that why it should happen only with a woman. Sorry, only with a girl child, because when it is X-linked recessive. Okay, let me just find out where did I find it. Okay, cool. Yeah. Why it is going all crazy on me? Just let me just take it. Okay, right here. So when it is X-linked recessive, uh, so what happens is, like, when there is a homogeneous X chromosomes, male child dies in the womb because it is that dangerous, and only the female children who have another X link get, you know, uh, expressed, like you see that in the clinical practice. So that was that. There is then non-CNS associated anomalies like erected thumbs, uh, which is likely because these children have spastic quadriplegia. Then you have Hertzsprung disease, which I did not know, and then he go on discussing the biology of that, and wow. So it's a laminin mutation basically, I think. L1, I don't know, like, you can figure it out. Just hold on 1 minute. Just tell me what it codes for, this gene, what it codes for. Okay, I can. Let's find out. Maybe some surface membrane. Yeah, it is L1 adhesion molecule. That sounds important one to be missing. Yeah. Wow. So yeah, it is important for neural migration. Duh, obviously. So there you go. That's the story of the mutation, which is on X-linked and causes all this. I should have written corpus callosum originates also to make it complete sense. And hydrocephalus. That's it. Yep. Cool.